Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video in the quadratic series on quadratic expressions. This time we're going to be working on distribution of polynomials in different quantities, and you'll see the set right here. I got 4 practice problems to do. I'm going to show a few more things on top with the rule. Let's go ahead and take a look right now. Distributive property. Distributive property says this. Here's the rule. When a quantity can mean any sort of number or set in parentheses or a variable. Just some sort of itemized value, okay? It doesn't have to be one term, it could be multiple. When a quantity is multiplied by another quantity that does contain multiple terms, the expression can be simplified as a sum of each term in one quantity being multiplied by every term in the other quantity. Okay, so it means this right here. If you have some guy on the outside, and I'll show you multiple versions of this, but if you have some guy on the outside of some other quantity right here, like this, the distributive property says, and I kind of did this with negatives in the last video, I distributed the negative. It says that I can multiply this guy inside here with every term inside this quantity right here. A is going to multiply with B, and A is going to multiply with C, like there, right? So that's kind of the idea behind it. Small one, case in point, let's go ahead and do one like this, 2 times x plus 3, okay? If I multiply the 2, I can multiply the 2 with the x and the 2 with the 3, and now I have 2 times x plus 2 times 3, which is 6. 2x plus 6, like that. That's basically what's happening there. Now, if you're not sure why you can do that, or let's see, not why you can do it. If you're not sure if the logic does agree with just all standard numbers here, let's take a look at doing it like this. What if instead I had 2 times 3 plus 4? Well, let's do this the conventional way. How might we do 2 times 3 plus 4? You might just do 3 plus 4, which is 7, and 2 times 7 is 14. But let's see if it still does work if I can distribute this way, 2 times 3 and 2 times 4 like this. Let's try that. 2 times 3 is 6, 2 times 4 is 8. 6 plus 8 is indeed 14. So it does seem to work out. It seems like you can do it either way. Now, why might you do it this way? Would you do it this way with all numbers? Would you instead just want to just add them up? Well, it depends. Most of the time, I would agree. I would probably just do 3 plus 4. You kind of order of operations, do the things inside the parentheses first, and then multiply on the outside. But understand that not everything can combine on the inside. Number one, like this one, x plus 3, I can't combine these. So the only way to get these out of parentheses and have the two truly affect it in a way that shows that simplification is I got to distribute. But here's the other one. What if you have a problem like this? What if I had a problem that said, let's see, I'll make one up. It says like 8 times 97. 8 times 97. And you don't actually want to do 8 times 97. See, I can rewrite 97 as a difference of two numbers that will make multiplying 8 by those numbers a lot easier. I can instead do 8 times 100 minus 3. See, 100 minus 3 is 97, but I rewrote it with numbers that I can multiply by 8 really easily. So check out this distribution, see if this kind of makes sense here. I can do 8 times 100, which we know is 800, minus 8 times 3, which is 24. 800 minus 24 is 776, I think. And that ends up being my answer there. So there is good reason to do this distribution thing sometimes. That's more of a mental math thing. It's nothing you'd actually write out loud, but that's the idea there. You can distribute and it's logically allowed, and that's what we're going to do here. So let's go ahead and get started on these on this one example here, this one in blue, and then I got to talk a little bit more about these other 3 and what we can do with it. All right, so this one in blue here, same thing. I'm going to distribute the 6y into the y squared, the 8y, and the negative 2. Now, notice here, it's not just a 6 that's distributing inside, it's also a y here. So let me just write out kind of a basic forefront on what this means. I'm going to multiply 6y by y squared. I'm going to multiply 6y by 8y, and I'm going to multiply 6y by negative 2. 6y is multiplying by all 3 terms inside here. Again, each term in one quantity, the 6y, is multiplied by every term in the other quantity, multiplies by the y squared, the 8y, and the negative 2. 6y times y squared, what we're going to do here, remember this is a 1y squared. When we multiply these things, it's not like combining like terms like addition, subtraction. They don't have to be matching degrees. When we multiply, the numbers multiply with each other and the variables multiply with each other. And the way variables multiply, I'll show you in a sec. 6 times 1 is 6. Y times y squared, That's y cubed. When you multiply another y, the exponent describes how many y's are being multiplied. Y squared means there are two y's being multiplied. If I multiply a third y, that's y cubed. So anytime I multiply that, it's just going to add on to the exponent. Y times y squared is y cubed. That becomes 6y cubed. So even though you just practice combining like terms, be careful because a lot of people make the mistake of not multiplying the variables together. That's why I say multiply the numbers separately from the variables. So this next one, 6y times 8y. Yes, I multiply 6 with 8. That becomes 48. But now I got to multiply y with y. Y times y is y squared. So that becomes 48y squared. Plus 6y times negative 2. 6 times negative 2 is negative 12. And there's a y that's multiplying with all of this. It just becomes a y right there. So there's a y that's left over there. It doesn't not combine. There's no extra squared in there. Think about it. None of these three terms could combine. They were not alike. So none of the three values in here should be able to combine either. There should be 1 degree more here. That's a cubed, quadratic, and now linear right there. So that's the end result of that thing after I distribute it. Nothing to combine with like terms. Eventually we will see combining like terms. Just depends on the problem. All right, so that's it for that kind of problem there, just multiplying a monomial. A monomial is a single term, with multiple terms, a binomial, trinomial, something like that, in the other quantity. Now let's look at multiplying binomials together. 3d minus 1 times d minus 9, these things like this. And I'll show you some stuff on top. Here before we do it. Now we're going to multiply a binomial with a binomial. So in this case, it's like I'm multiplying an actual quantity expressed with multiple terms, a plus b, times some c plus d, like this. All right, that's what's going on here. Now, here's what happens. This is still a quantity. When a quantity is multiplied by another quantity, the expression can be simplified as a sum of each term in one quantity. Here are the terms in one quantity, a and b. Each term in one quantity being multiplied by every term in the other quantity. So each term in one quantity, this a is going to multiply by every term in the other quantity, c and d. A is going to multiply with c, and a is going to multiply with d. Okay? When I do that, I'm going to get a times c, ac, plus a times d, which is ad. Now, that's not the only term in this quantity. I said each term in one quantity. I did the a with c and d. Now let's multiply b with c and d. The other term b multiplies with every term in the other quantity, c and d. So that's plus bc plus bd. This isn't really a formula. I don't want you to memorize this as any formula. I want you to understand the rule. I'm using this idea with general letters to make sense of what it is that we're about to do in these future problems. It gets a little confusing with the arrows. I'll show you something else when I do this next problem here. But that's the general idea here. Each term in one quantity multiplies with every term in the other quantity. So in this bottom problem here, I'm going to take the 3d minus 1 and treat them separately. Notice that a never multiplied with b and c never multiplied with d. A adds with b, c adds with d. So I'm going to do 3d. I'm going to multiply it with d and with negative 9. 3d multiplies with d and with negative 9. And when I write that out, I'm going to do it simply first. 3d times d plus 3d times negative 9 here. Now I got to multiply what? Negative 1. Don't forget the negative as a part of this. Negative 1 with d and negative 1 with negative 9 right here. So in this case, in this particular instance, I'm going to add in between though, because I said as a sum of each term. So I'm going to add negative 1 with d, and I'm going to add negative 1 with negative 9. Don't worry, I'll shrink this or erase this later when I get to that next problem. Just move this over just a hair. All right, so in doing that, let's go ahead and multiply these things out. 3d times d, remember that's 3 times 1, which is 3. D times d is d squared. Plus 3 times negative 9, that's negative 27. And then there's a d left over. Plus negative 1 times d, that's negative 1d. I'll just put minus d, see if you can remember that. Plus negative 1 times negative 9. Negative times a negative is a positive. 1 times 9 is 9. So I get plus 9. And what you're going to get in a lot of these problems here, not every single one, but in a lot of these problems here, you're going to be getting some instance where you can combine some like terms. Here's a d squared. Here's a d. Here's a d. Here's a constant. So d squared can't combine with anything, but these two d's can combine together. This is negative 27d minus 1d. Negative 27 minus 1 is negative 28. So I'm going to combine those two, and then I'll write the rest as it was. So 3d squared minus 28d, whoops, plus 9. That is a d right there. I'm sorry about that. And that ends up being the final result there. All right, so I'll keep this here for now. Once we get to this problem, I'm going to have to erase it. So, you know, you pause or rewind to go back to this problem if you need to. I'm going to do the purple one to start the next part anyway. Okay, so before I do the next problem, I just want to state that sometimes they use this method here that's called FOIL. And it's the same thing as what I just did in this last problem here. I'm not going to say this very often because I can't do it with this problem, for example. But to remember this a little bit better, there is something you can do. It's called a mnemonic device, FOIL. FOIL, F stands for first. You multiply the first terms, A and C. The first terms are the first terms in the quantities. Multiply the first terms together. O stands for outside. You multiply the outside terms, A times D. A times D. I stands for inside. You do B times C. L stands for last. You do B times D. So the FOIL method is kind of also what you can say as well. And if you want me to spell it out this way just to get this one started, I will. So in FOIL, F-O-I-L, I'm going to go ahead and get the first terms. Let's do W times W squared. That's W cubed. The outside, W times 2W. That is 2W squared. Again, W times 2W, you multiply the W's together. Inside, 5 times W squared. That's 5W squared. And then last is 5 times 2W. 5 times 2 is 10. You get 10W right there. We got to add all these things up now to get the final result there. I'm not going to write any other problem like this. You might see me in an old video do it, but future problems, no. When I add these up, I just got to combine the like terms, and here the W squareds can combine, so I'm going to get W cubed plus 7W squared plus 10W. That's the end result of that guy using the FOIL method. I did the same thing as the last problem. Remember that. Make no mistake. This is no different than what I just did in that last problem. I just had a mnemonic device help me out with what I multiplied and where. So there's that one. So that's the FOIL method there. Same thing. Now I can't use the FOIL method in this last problem. I said I'd delete this, so here it goes. 3, 2, 1, bye. In this last problem, I can't use the FOIL method because what would FOIL give me? If I did the first, outside, inside, and last, notice there's a problem here. Nothing ever multiplied with 3x. So I can't FOIL. And I don't want to come up with another mnemonic device. FOIL are the training wheels to help you understand distribution. Eventually, we got to take off the training wheels. So if you learn FOIL at some point, eventually you got to tell yourself the whole multiply each term in one quantity with every term in the other quantity. And that's what we're about to do here. So x and 4 are each going to multiply with all of x squared, 3x, and 2. This can get a little clunky here. So x times x squared, x times 3x, x times 2. I'm going to get all three of those. Then I'm going to do 4 times x squared, 4 times 3x, and 4 times 2. Okay. I'll let you know right now, there is not an easier way to do this, but sometimes people represent this in like a box. I'm not going to do it this way, but if you see it in one of my videos, maybe you'll make sense of what I'm doing there. You can multiply this as if they are sides of a rectangle. And then you do this so like x times x squared is this, x times 3x is this, and you kind of write it inside the box. It does help for some cleanliness when the polynomials get very big, or when you have to deal with negatives or all that good stuff. So x times x squared here, see if you can make sense of the arrows. X times x squared is x cubed. Let's find my color here, 1 second. X cubed. X times 3x is 3x squared. X times 2 is 2x. Then 4 times x squared, remember now we do the 4 times these three. 4 times x squared is 4x squared. 4 times 3x is 12x. And 4 times 2 is 8. All of these were at pluses. They're all positive, so we're going to add them all. All right, now we got to find like terms to combine here. So there are no more x cubes. Here's the only x cubed here. I'll just go ahead and cross it out as I find it. Now I'm going to find the x squareds. Again, go down in descending order of degree, standard form. 3x squared and 4x squared can combine. So 3x squared plus 4x squared is going to give me 7x squared when I combine them. 1 second, let me get my color. 7x squared. Then I have 2x plus 12x. 2 plus 12 is 14, so that'll give me 14x. And then plus 8. That is just that last remaining 8. Go ahead and cross that out. And then I'm done. I've simplified this one all told. So there's the distributive property in a nutshell. That's the basics behind it there. Again, each term of one quantity multiplies with every term of the other quantity. When there are negatives, make sure you distribute those in as well, and you combine like terms in the end, write things down in standard form in descending order of degree. Let me rewrite this answer here, but that ought to do it for this one, guys. Negative 28d plus 9. All right, that ought to do it for this one, guys. In the next videos, we're going to be starting to look at some factoring. It gets a little busy in factoring, so hopefully start to make sense of it. I'll do one bit at a time there. You'll see bit by bit and make sense of that. In order to do factoring, it would make sense that you know not only how to do distribution, the distributive property here, especially with the FOIL idea, you know how to do the distributive property, but also that you know factors of numbers. You know the times tables of certain numbers, if that makes sense. All right, that's it. Take care.